আসছে না, দাঁড়াও। হ্যাঁ, এসেছে। ওকে। Yes, 29 all have joined, so no problem. Now, what I have done, I am just sharing my desktop. Present now your entire screen. Can you see my screen now? Is it possible? Sorry. Now, can you see my desktop? Okay. You are seeing my desktop. Okay, okay. See here, I have downloaded this PSpice student version 9.1. I think this is the freeware version. You can download it in the net without any price, etc. So as I have told you, someone enter. Hmm. Uh, Actually, due due to the problem, I cannot go avail the university system. So I have to proceed with the things that are freely available, that I have already told you in the first class. So for that I have downloaded this PSpice 9.1, and there when you install, please take a note what I have told you in the group to take your copy. Those who have installed or wants to install, please install the schematics, because uh, uh, otherwise you can do it in other software also, but to get a tuning with me, what I am doing, if you want to just cross verify or do in the same way, then you will have to install the schematics, because that is easiest what I have found. And when you install the schematics, you will see here the app will be installed like this is the icon. So when you will open this file, this schematic window will be opened. Now what to do here? First of all, see the basic circuit diagram here. Can you see the cursor? Okay. Here the basic thing is the bridge rectifier. So, but before simulation, just I tell you my idea behind this simulation. What happens? What I have told you in the previous simulation, you have done about sinusoidal voltage, current, phase difference, etc., and that is from the copybook. You have designed a software. The user will input anything and will get the pictorial view of the wave shape, that what is happening there. Very good. Now we will come to the practical system. Just look at your laptop. Each of your laptop has a power supply module in it, in which you plug in to the main supply. You have, otherwise you have desktop computer, you have printers, scanners, televisions, sound system. Everything nowadays uses the SMPS structure, the switching mode power supply structure. So if you see, the switching mode power supply is what it does. The input circuit of the power supply is a bridge rectifier. It makes the alternating current DC, and this, the 1000 microfarad, 1000, so disturbing. There's some দুয়ারে সরকার, হ্যাঁ, দুয়ারে সরকার প্রকল্প চলছে। হ্যাঁ, ঠিক আছে, থ্যাংক ইউ। প্রকল্প এসছে, সেটার জন্য মানে ভিড় কি বাইরে, মনে হচ্ছে। হ্যাঁ, মানে সিরিয়াস অবস্থা। যাকগে। So a 1000 microfarad is the filter capacitor. should I explain how to place this component, or you know? That you just confirm me, then I can explain also.
Yes, sir. Just give a brief idea, sir.
Brief example. Okay. When you open this schematics, you will see that there is this icon like the binocular দূরবীন icon আছে একটা, এই যে দেখতে পাচ্ছ get new part. হ্যালো, হ্যাঁ একটু কমিউনিকেট করো, নাহলে আমি বুঝতে পারছি না হচ্ছে কিনা। হ্যাঁ, আচ্ছা আচ্ছা। তো এই get new part এ when you click it, you will get all the parts. Okay, now for diode, first of all, this bridge rectifier, you need 4 diodes. Just I am typing D. See, there is D1N4002, 1N4148. For your information, just I am telling that this 1N4002 is the power diode or rectifier diode, and 4148 is a signal diode. So to rectify the input signal, you need power diode like 4002. So you just see, place and close this window. I am doing that. You will get the diode, and you just place like this. Okay, now how to make it reverse? Just control and rotate, control plus R. Control plus R will just reverse the directions. Did you follow? Okay, now if you want to reverse the direction, you can do this. Now place like this. So it will automatically place with the part number D1, D2, D3, D4, etc. See, I'm placing it. D5 is now there. Okay. Now, how to avoid this icon? Just press the escape button. It will go. And here, if you see, if you place the escape button, now the cursor, the arrowhead can move this anywhere. Or even if it is red, you can delete it by pressing the delete button. That part is done. So make it clear that you can place the diodes. This part is clear. Now about the connections. See, I want to edit the connections. If you press the mouse here, it will be red line. You can delete it. Now how to make the connections? See this icon carefully. This is the reason I have told you to take a copy and pen. The pen, there is a thick draw bus. I don't need bus lines, and is ordinary wire line. I will press this icon and see the cursor changes to a pencil. Did you see this? Now if you you just click once here, the start point will be defined. Now without clicking, drag it and click again here. It will be joined like this. Now you press the escape button, the pencil will go and change to common cursor. If you click the cursor in the right anywhere, it will be changed to green. So in this way, bus lines are drawn and parts are placed in this way. Now I want to put the capacitor of 1000 microfarad. What I will do? Put here the part icon, the binocular icon, and just type C. Just C. C is the capacitor, only C. Now place and close. See, capacitor will be there. But see, the capacitor is in rotated position. What I will do, Control plus R, it will rotate and just place here. But what is the value? It is only 1 nanofarad. I want 1000 microfarad. Now what I am doing, I am putting the escape key so that it vanishes. Now double click this value. It is 1n. I will just write 1000 U. U is the sign of microfarad. uh, Note it in your paper or on your page that I have told the symbols are very important. What are the symbols that are valid? For resistance, I will search for R and I will get this is the R, this is the R. Now see 1K is the kilo ohm, small k. What are the values or units? If you write only 1, it will be 1 ohm. Okay. If you write 1, then you can 1 to 1 kilo ohm, you can write in this way 1, 10, 100, 50, 25, 73, whatever, it will be in ohms. 1K is the kilo ohm. How to write milliohm if I want? It will be 1. Please note these things. That is why I am repeatedly telling. Milliohm is small m. Okay. This will be 1 milliohm. How to make it 1 mega ohm? The same m? No. It will be 1 meg. If you give other units than this, it will not be valid. That is why the list of valid units you must know. 1 meg is the mega ohm. 1 only m is the milliohm. 1 k is the kilo ohm. Okay, this part is sufficient for resistance. Capacitor 1 P is 1 picofarad. 1 P is the 1 picofarad. After pico, I have 1 nanofarad. 1 N is the nanofarad. Are you taking the note? Otherwise, you cannot simulate without these proper values. 1 N is the nanofarad. 1 mu is the microfarad. And that is enough, I think. So these are the common units that you are using for capacitor and resistor. Now see, if you put here R, you get resistor. You put C here, you get the capacitor. You put D here, you get the diode. That part is completed. Now, how to draw this? I will put 1000 microfarad capacitor as filter capacitor. The bridge rectifier you will search and find. I think you have done several times this bridge rectifier, so nothing new. You will just interconnect the diode like bridge rectifier. I have done in my way. You can do whatever. So you just look at this part carefully. The block. This is the bridge rectifier and the filter capacitor, and this is the main block that every SMPS uses at its input. Main major block to make it DC from AC. After this block, there is the resistance. This resistance is the load, the circuit of the SMPS. You are drawing the current for charging the laptop or running the printer, running the washing machine, etc. So this is the load. I have put it resistive load of 10 ohms. Why 10? Because I want to see the current of a sufficient magnitude so that I can plot it. That is your discretion. You can write 10 meg ohm also. What will happen? The current will be so small that you will not be able to plot. That is why, nothing else. And a large filter capacitor so that I get the DC here. Now, forget about these things. Just the basic circuit is for this bridge rectifier, input of the bridge rectifier, just put the AC supply to connect the bridge rectifier. Forget this resistance. Directly you can connect the AC supply. How to connect this AC supply? I am just I am just searching here. Be careful. There are two AC supply. One is, if you just type V here, V for voltage, can you see that two are there, VAC and VDC? Sorry, VAC is there, but that is not the AC we want. That is for frequency sweep. Please keep a note. It will be very easy to mislead ourselves. And I am saying, okay, this is VAC. I will just place and close it. And the icon is also same. I can make it very much mistake with this VAC, and this is the common mistake students do. The icon is also same. See, the same icon, and this is also VAC. So what is the mistake here? I have put VAC, but that is for the frequency sweep. That is not for our VAC. What we will do, you cannot plot waveform from this VAC. What we will search? We will search for V. See carefully. VSIN, V sine, sinusoidal wave. See, V sine is there. This is the V sine, same icon. You put this V sine here in place of V4. And if you connect, now this V sine will have to be configured. What to configure? Make a note. Exactly. That part, if you have done simulation, everybody should know that nothing, amplitude 80, I have put 80, frequency 50, and offset 0. These three parameters, offset, please, those who have forgot, just recapitulate. I will put only the three main parameters and forget about other many parameters: offset, amplitude, and frequency. If you put these three, frequency is 50 without any unit is hertz. If you put 50k, that I have told you already, k is the valid unit for 50 kilohertz. 50 MEG you will have to put, not only M, it will be MEG, then it will be 50 megahertz. If you put 50 only M, it will be 50 millihertz. So I will put 50, and amplitude I have put just 80, and offset 0. Otherwise there will be a DC offset which is not present in our normal power supply. Now to connect the bridge rectifier, what I want to see, I want to see the, I am just deleting all the irrelevant things so that you will be able to understand. This is the basic circuit. Again I repeat, this is our bridge rectifier unit. Outside the block, this is the load, and this is the simple source that I have connected to the bridge rectifier with amplitude 80, frequency 50 hertz, and no offset. Now how to read the current? Oh, another thing I have forgot. This, the across the load, I will have to put some earthing terminal here. Otherwise the reference with respect to what is missing in the PSpice. That is very important. How to do that? What I do, I just search for G for ground earth. See, ground earth is there. You place and close, put it here and just place it. See, done. That is part of the ground earth. So what is done here? The reference point is defined. Now what will happen once you place this D, C, R, etc., everything will appear in history here. You will not have to search it again. Now if I want to find R, it's just I will go here and just click it, the R will be present here. For the first time, I will have to search the inventory. Since this inventory is huge, for the next time, I will just use this my custom history. Okay. Now I have connected the voltage source to the rectifier. But how to measure this current? First of all, I want to measure this voltage. That is very important. I will have to do a differential probe. I have to get a differential probe. See this, it is in the markers. Here at the marker window, it is in the marker window. Okay, somebody has, I think, resent. Just I'm saying that. Who have sent? Some number is coming. Ashish Kumar. Not coming here. Ashish Kumar has sent. It's not present here. Okay, I will see later. Okay, now mm, so I have done this thing. Now, what is the voltage? For voltage, the markers mark voltage differential. It is not absolute voltage level, because understand the things very carefully. See, where is the reference point? It is here after the bridge rectifier and filter. So if I want to measure the actual voltage or the simple voltage with respect to earth, I can measure here with the help of this absolute voltage. This is the mark voltage level. This is the absolute voltage with respect to earth. You will get a DC here. Okay, let us simulate that. I have put the absolute voltage here. Now the simulation setting, it is this icon, setup analysis. Okay, in the setup analysis, in the
Sir,
setup
can you please
analysis,
explain the absolute voltage part?
yeah. Again, I am explaining. See, you have a reference earth here. Turn on your mic so that you can
Yes,
tell
sir.
me that you have understood. Okay,
Yes.
this part is clear that this is the
Yes, sir.
earth. Okay, now with respect to earth, BSpice analyzes everything. That this is the reference voltage, this is the 0 volt. With
Okay.
respect to this, some voltage will be changing, etc.
Okay.
Now, if I want to measure with respect to this, then I will put the simple voltage marker, or from the markers mark voltage level. So this voltage here at this point where V is marked will be with respect to ground. If you make it here and if you simulate, it will be 0 voltage.
Zero.
That I will also show you. Now first of all, setup, that is very important. To
Okay.
simulate and show the results to you, first of all I need to set up the simulation software. In the setup, just remove all the tick and mark the transient part. Actually this transient means time varying signal. If it is clear to you, see, all ticks are removed, only transient I will tick and I will click here. It is a button. Okay, now I am clicking here. Look these points very carefully. Print step, just forget it. It is 0 nanosecond by default. Now you have 50 hertz. Each of the cycle has how much time? 20 millisecond. Did you recall that each of the cycle has 20 millisecond? I will just, how many then cycles are here? 60 milliseconds. Okay. N means nano. I think you remember 60 M is milli and MEG is mega. So MS means 60 millisecond. Now there is a peculiar thing called 40 millisecond no print delay. See, is it possible if you measure in practical life, you just, when the sine wave will start, I will measure that point. Is it possible? Do the power supply wait for you and start suddenly? No, it is impossible. So what happens? I will have to measure from a intermediate part. That is why I will not print up to 40 milliseconds, so that what 60 millisecond is the final value and start is 40 millisecond. That means I will just print one cycle, but in the middle of the system. That is why I will get from 40 millisecond to 60 millisecond, a one cycle, but not at the start, so that I can avoid the starting condition, which will not be present in practical cases. Now, what is the step ceiling? This is the same thing that I have explained in the Excel, that how many data points you want to plot in 1 millisecond. If the ceiling is 0.2 millisecond, you will see, I think approximately in 20 millisecond you will get 100 points. Isn't it so? 0.2 into 100, 20 millisecond. So I will get 100 points because I will have to plot it in Excel, etc., etc., and see. Done. So is this part clear, or should I explain anything you require? These steps, print step, forget it. Final time is 60 millisecond. No print delay, that means the start time is 40 millisecond, and ceiling is the number of data point, it's 0.2 millisecond. Who is there? I am sharing the screen so I can. So is it clear? So after you set up, now who has asked me? I have just forgot. Then you can close it. Now see, if you put here the probe, absolute probe, this is the reference. Now I just simulate it. This is the simulation icon, the yellow icon. This is the simulation window. What is the voltage? 0, because I have put the probe itself in the, exactly. Now is it clear? Who was asking me that to explain me?
Yes, sir.
That is the reason. Now with respect to reference, I want to see here. What you expect here? First you tell me. It is the DC and filter capacitor. Some DC value I expect at the simplest. So let us simulate again. Simulation icon. This is the typical DC with ripple. Now see, it is starting with 40 millisecond and ending in 60 millisecond as we have expected. Isn't it so? Actually, this ripple is not this much. If you see, it is starting from 40 to 80. So if you change this will be your task. Everything I will not do. If you change it 0 volt, and if you see it 80 volt, see the ripple will be much reduced, and it will be reduced to a DC line. User defined. if you put it 0 volt, 0 to 80 volt, the ripple will be like this. That means approximately 60 volt is the average line. If you see just the visual inspection, this is the DC voltage. This is with respect to earth. So this part is done.
Sir,
Now,
from where you have got that dialog box where we have changed the user defined axis?
haha, I will not tell you because this is your task. If you just search it, if you don't find it, then in the next class I will discuss it, because you will have to do something by yourself. Just you play with this software. If you
Okay, sir.
double click actually the axis, it will get nothing. If you double click it, see, I'm double clicking. Got it?
Yes, sir. Thank you, sir.
Okay, okay. Now, this is the absolute voltage, but this time, see the reference is here. If I want to measure here the voltage, it will be something complex thing. I just want to measure the potential difference across this source. That that is the case when the markers will come to play. Mark voltage differential. First one you place will be the plus sign. See, plus, and another will be the minus sign. For DC it matters, and for AC the phase will matter. No problem. I will just, I am just wanting to measure the differential, voltage differential, and I just place across this voltage waveform. Now let us simulate. Again, see the pure sine wave, classical sine wave. If you delete the voltage differential, both will be deleted at once. Now I want to measure the current from this source. I will put a shunt here. How to measure the current? Simple, put a shunt. I think you have done, did you do this laboratory or anything by putting shunts, etc.? Oh, okay. Uh, I got it. Just put a simple resistance here in series, okay? Voltage drop across this resistance will be the proportional to current, because this is a simple resistance. I think ideal resistance here in the simulation. Now I will have to change this to a very small value. Why? Because 1K is a huge value. The current will not be going to the main circuit. It is only 10 ohm load. So I have put it, changed it to only 1. Without unit means 1 ohm. Up to this it is clear. Then how to measure this potential difference across this resistance? With the help of differential marker. I want to measure the difference that will be current. The markers mark voltage differential. First one is positive, that one, next one is negative. Escape, it will go. Simulate it. Sorry, simulate it. See, peculiar type of current. And that is the reason I was telling repeatedly that practical current will not be a sine wave. And if you do all the sine wave calculations by phase diagram or the phasor diagram, etc., it will be very difficult to cope up with the practical situation. Now our task will be to measure this voltage, current, absolute or the true RMS value, the true power, etc. That is my ultimate target. I have already told you. Let us start by this simulation, and this is the current wave. Obviously, the current wave will be AC, but the AC will not be a pure sine wave. Now there is a problem. how to export this value to the Excel. Otherwise, I cannot do the calculation according to my system. Up to this, is it clear to everybody? Okay. So I will simulate this diagram. I know how to plot the current. I know how to plot the voltage. Okay, let us mark the voltage also. Mark voltage differential also. Control plus R. Control plus R. I'm just rotating it, otherwise it will clash with the icons. Now I have both voltage and current reference. Let us do the simulation. See, this is the voltage, and with respect to voltage, the red one is the current wave shape. Okay. Now in Excel, I will have to plot this voltage wave shape and the current wave shape. How to do this? See very carefully. In the search, you just search for vprint. VPRINT. Vprint 1 is there, vprint 2 is there. What is vprint 1? Place and see. Vprint 1 has only one probe. Can you see? Only one output. That means this is the absolute value, but I want differential value. So in that case, I will search for vprint 2, which is the differential print. Place and close. First of all, you place it and see the icon carefully. Can you see there is a minus icon there, small minus sign? That means this lead will be the minus terminal. So I will have to match with this minus here. So I will just rotate, Control R. No, the minus is going the other way. R, R. Okay. So minus and minus matching. Now I will connect with the help of wire. What is remaining? The voltage, the current part is remaining. Again, vprint 2. Now in the history it will appear vprint 2. Minus is matching. Yes, it is now matching. I will just put. So what will happen? Voltage and current will be printed. Let us simulate again. What happens? Nothing happens. Now if you see analysis, again you make it a note. Actually, what happened? Now he wants to join, or otherwise I think he has disconnected or what? He was disconnected. Oh, okay. Now I have the print of voltage, print of current. I have simulated it, nothing happened. Here in the analysis, there is a, I think, examine output is there. In the examine output, you will see there are certain simulation, etc., which I don't need now. Here you will see the time versus voltage, or time versus current, time versus voltage is there. To separate, I will have to put these things in Excel. What I will do, very simple, just copy. Just copy it and paste it. I have pasted it. You can see this is the current waveform. Pasted it in the notepad. and this is the voltage waveform. Now we will get the time increment also in the left, in the right the voltage. Now open in Excel. I am opening it in Excel. File, browse, all files, desktop. Where is the, first of all, let me open the voltage waveform. This is the delimited field, because I see there are two things, one is time, one is voltage. So put at this next and space as the separator. You can see if I remove the space, no delimiter line is appearing. That is wrong. If you have this line, then two columns will be separated. Can you see this? Then next, finish. See, this appears, and this will be the time. And just if you plot, see how many data you expect. 100 data. See, this is 100 data. 1 to 101 actually, or 2. Yes, approximately 100 data. Because did you remember that in the simulation I have given the transient as 0.2 millisecond? That will control your number of data points to handle. So I have got 100 data in the Excel. Let us just insert. This is your voltage. Done. The voltage part is done. In next column, you will place the current. See the current I am opening in another file. That will be your work to plot and arrange. So where is the current waveform? Got it. Again, it will be a delimiter. Delimiter is space. Next, this is the current waveform. Let us see. See, this is the current waveform. If you put it side by side, then the same simulation result will be there, voltage and current side by side. So up to this will be today's task. I will give you again 2 weeks time. Is it sufficient? 2 weeks? Okay. Excel you don't have to submit me. You can submit this screenshot that you have obtained this. But again I tell you, I have no bar because of this peculiar situation. I don't know who has the access to which software. If you can do it in MATLAB, in other software, in other free software available in net, whatever you do, my ultimate target will be to measure these true RMS values and powers, what is done in the smart metering system. Actually, if this is the peculiar waveform, then you will see that almost no power will be detected by our classical metering or the rotating disc or the mechanical system. It will be a very erroneous value, and that is the reason we need the smart metering system to develop, so that the consumers cannot escape with by producing peculiar waveforms and escaping the uh, electric bill. Even I can place an heavy inductor in series and make the situation worse, so that almost the power will drawn will be zero, but I will utilize my whole power of the house without giving proper meter or proper bill. So I need smart metering which will analyze this waveform and show the true power. That is my final target. So up to this, in the Excel file we will produce the wave, and in the next class, Rohit, what you will do, it is your job, you will send me in via mail or WhatsApp, whatever, the Excel file by arranging the time voltage and current with which we will start and explain it the next task to you. Just this file plot. What you will do, just there will be the time, this will be the voltage, this will be the current, and the superimposed voltage current waveform chart here. This file you will send me, so that I will start with that file. And today is what date? 10th, 17, 24, 24. I think it will be again holiday, or what matters with holiday. 23rd, yeah, 23rd, we will again meet and discuss the further progress. So, first simulation, what I have told you, that will carry 10 marks. I think everybody has got 8, 9, or maybe full 10 marks. I will not deduct the marks. So, 10 marks. Very easy. The target for the following circuit diagram, you will first, what we will do, first the target is to plot the voltage and current waveform. This is that is the point number 1, the objective actually, for a circuit which will involve non-sinusoidal current waveform. Done. Now the next part, the circuit diagram. You will explain the bridge rectifier, filter, and then the screenshot of the circuit diagram, and the values will be there in screenshot, what values you have chosen. And next, the simulation result, the screenshot of the simulation result in proper units, etc. In graph, that 40 millisecond to, you will explain why it is 40 millisecond to 60 millisecond, because the starting of the waveform is never obtained, etc., etc. This part will be your report. Exactly. To plot the waveform for a circuit which will not involve conventional sinusoidal system. Ha ha. Ha, yes. No, 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 no. I will split the assignments, because see, I have to fulfill two targets. I am not since I am the teacher. My responsibility is much more than you. I will have to complete at least 3 assignments before any adverse thing happens, so that I can send you the send the marks. So that part I am concerned more than you. So what I am doing, this part will be again 10, so that you get 20 marks before this Christmas. And that day we will discuss the third assignment, and I think within January 10 your session will close. So that part I will be taking, see the calendar, let us see. So 23 we will discuss, and this will be the Christmas session. I will take it on, say, 7th or 8th or 9th. Okay, and that will be the almost over, because within 13th I will have to prepare full marks and make it ready, because this is the sessional is very important. If you fail in sessional, yes. So be careful. So 24th you submit the second assignment, and we see, we are more confused than students. So we will have a meeting in Friday night, the teachers meeting, It is a huge concern because not only you are thinking only about the semester and theoretical subjects, what will be about the practical, which carries a huge marks. So let us discuss. You can just remind me in the middle of the next week. You can call me. If I get any information, I will tell you. Uh, so all the other students